All right, so that was kind of a distraction. We'll get back to elementary matrices later. Let's get back to determinant. Now, I realize that this is perhaps not going to be very satisfying for some people because this definition is not motivated, but you'll just have to bear with us. That you have to understand that this definition was motivated by experience, by long experience, and you're kind of coming in at the end. Later on, you'll see its usefulness. All right, first of all, before we define matrix, we have to define determinant. We have to define submatrix. And submatrix, we have this notation that the submatrix A, parenthesis I/J, is the smaller matrix obtained by removing row I and row J. Okay, so I think you can understand from this picture, A2/3 means remove row 2, column 3. I think I said row 2, row 3. It's row 2, row I, column J. So if I'm going to remove row 2, column 3, you can see I get 1 minus 2, 9, 3, 5, 1, which is exactly here. If instead I remove row 3 and column 1, that goes, and and then I get this part here, minus 2, 3, 9, minus 2, 0, 1, which is exactly here. So that's how you form a sub-matrix. All right, now here's the definition of the determinant. It's kind of complicated. The determinant of a 1-by-1 matrix is the single entry in the 1-by-1 matrix. Now, this inductive definition, so you build up a determinant of a matrix from its determinant of a submatrices. If a matrix is bigger than or equal to 2, we have this long drawn-out definition that looks horrible. Let me just point out some facts here. The determinant is a matrix entry times the determinant of a submatrix, minus this matrix entry times the determinant of another submatrix, plus this matrix entry times the determinant of a submatrix. So what that means is that to get the determinant of a matrix, you have to build it up from determinants of submatrices. Now, how do you find the submatrices? Well, you have to build that up from smaller submatrices. So you've got to go all the way down. Okay, so this is hard to swallow just from here. Let's just do an example. And you may have seen this procedure before. The way you take the determinant of this is we're going to look at the entries along the first row. Okay. The first entry is 3, second entry is 2, last entry is minus 1. 3 entries there. Okay. Now, if you notice that these coefficients 3, 2, minus 1 are exactly these coefficients here, 3, 2. Now the second one has a minus sign and minus 1. Okay. The signs on these coefficients alternate. Okay, so you can see where these coefficients come from. All right, now we need to get these submatrices here. How do we get these submatrices? Well, first of all, to get the first submatrix, we remember the first entry was 3. I'm going to cross out this part and take that submatrix. And that's exactly what I have, 1, 6 minus 1, 2. So that's where this comes from. So this first term comes from this entry times the submatrix obtained by crossing out the row and column. Okay, how about the second one? Second one is going to be this entry. If I cross out this row and this column, I get 4, 6 minus 3, 2. There it is right there. The only difference between this term and this term is that this one has a minus sign. Okay. Then finally, the last entry. The last entry is obtained by taking this minus 1, cross out the row and the column. You get this matrix left, and you have this matrix here. All right, now we're not done yet, because we need the determinant of this matrix. You may know the formula for a determinant of a 2 by 2 matrix, but it still follows the same pattern. If I want to take the determinant of this, I'm going to take this, and the first term is going to be this entry, cross out this row and this column, times the determinant of what's left. Okay, so that's where this comes from. Okay. Then the second part, the second term, well, I'm going to take this entry, cross out this row and this column, and take the determinant of what's left. And there's a minus sign, just as before. The second term has a minus sign. All the even terms have a minus sign. And that finishes the determinant of this first matrix. Let's go on to the second matrix. The coefficient 2 remains. if I want to take the determinant of this matrix, I'm going to take 4, cross out the row and the column. What's left is 2. Okay, and actually the determinant of 2 is 2, so I'm done with that. And then the second term is going to come from 6, cross out the row and the column. You have a -3, and you have a minus sign to lead it off. Okay, all right, so that's simplifying, that's evaluating this second matrix. For the third matrix, notice I have the -1 here, which gives me this minus here. That goes there. All right, so to find the determinant, I'm going to take 4, cross out the row and the column. That gives me -1, so that's where this comes from. Then the second one, I have a minus. This is the element. I cross out this row and this column, and then I'm going to get times -3. So there we go. As we mentioned before, the determinant of a 1 by 1 is just the number itself. So now you just have to work out all of this algebra. Make sure you work from inside out. You do the products first. So this is 2 plus 6, that's 8. 3 times 8 is 24. Then here we have, 8 plus 18 is 26. Times 2 is 52. So that gives me -52. And then here I have 4 times -4 plus 3 is -1 times -1 is 1. So you get this and you get -27. Okay. Okay, so this is a long procedure just to get a 3 by 3 matrix. A simpler way is to get a formula for this 2 by 2 matrix. We just generalize the procedure that we had, and we get this formula. So you notice that this formula comes just from how we did take this A, cross this out, and I get D. Then the second stage is I take a minus, and I take B, cross these out, and I get a C. Okay, so for 2 by 2, you probably know this formula already, but the determinant is equal to this simple product. Diagonal entries minus off-diagonal entries. Okay, I guess I'm going to stop here.